This section we're going to be going over expected value or expectation. They mean the same exact thing. So for expected value, the expected value is going to be used to determine the expected results of an experiment over the long term, so over a long period of time. So this is going to be used to help make decisions in areas like insurance, business, and games of chance, and many other disciplines as well. So the expected value, which we're going to be denoting with a capital E, is going to be calculated by multiplying the probability of an event occurring by the net amount gained or lost if the event occurs. Then, if there's multiple events, we're going to add up all of the individual products. So this formula here is going to be the expected value equals P1 times A1 plus P2 times A2 plus P3 times A3, and so on. So P1 is the probability that the first event will occur. A1 is the net amount won or lost for the first event. P2 is the probability that the second event occurs. A2 represents the net amount won or lost, and so on. So it is important to know that the A values can be positive or negative. And as usual, the percents, the p-values, or the probabilities rather, not the percents, the probabilities have to be between 0 and 1. Okay, so the expected value, what this actually is, it's essentially a weighted mean. It's an average. So the expected value is an average result that would be obtained if the experiment were to be performed a large number of times. Okay, so let's see an example here. So JetBlue Airlines is considering adding a route from Boston to Minneapolis. Before making a decision, the company needs to consider many factors, including potential profit or loss. After considerable research, JetBlue estimates that if it adds the route, there's going to be a 60% chance of making an annual $800,000 profit, a 10% chance of breaking even, and a 30% chance of losing $1 million. So we want to know how much can JetBlue expect to make annually on this new route. So if the answer is positive here, then it's in their interest to add this route. If it's negative, then it's in their interest to not add it. Okay, so we have three different cases here. We have either they profit, they break even, or they lose money. So that means we're going to have this set up for the formula with three different cases. Okay, so if you want to, you don't have to do this. You can set up a little table and write down all of the outcomes, which are the A's. So the outcome 1 is that they make positive $800,000. Outcome 2 is that they break even. If they break even, that means they make $0. If they lose $1 million, that means we have to put negative $1 million. So this is where it gets a little tricky. You have to make sure if you're losing money, you have to make sure you include the negative. Okay, and now the probabilities for each one. The probability that they make $800,000 is going to be 0.6 because we need them as a decimal. So remember to change a percent to a decimal. You move the decimal point 2 to the left. If the decimal isn't written, it's assumed to be at the end. Okay, so then a 10% chance of breaking even, that's going to be 0.1. 10% as a decimal is 0.1. And then 30% as a decimal to lose $1 million is 0.3. Okay, so just don't forget, every time you're changing a percent to a decimal, move the decimal point in the percent 2 to the left. Okay, so let's go ahead and plug all these values in now. So it's going to be expected value. P1 is going to be 800,000, or sorry, P1 is going to be 0.6. That's going to be the probability. Order doesn't matter though. So 0.6 times the outcome of making 800,000 plus the probability for event 2, which is going to be 0.1 times the outcome of 0 plus the probability of event outcome 3, which is 0.3 times that outcome, which is negative 1 million. Okay, so what you would have to do here is you can go ahead and plug this all in a calculator. Just make sure your order of operations are correct, which the calculator should take care of. So plugging this in, we should get $180,000. So make sure you have units on it because this is money. So this means that in the long run, after a long period of time, they should expect to make about $180,000 on average per root. Okay, and I just threw in the phrase on average there. Okay, let's do a couple more examples here. So the next one is Maria is taking a multiple choice exam in which there are 5 possible answers for each question. The instructions indicate that she'll be awarded 2 points for every correct answer, and she will lose a half point for each incorrect answer and receive no points for answers left blank. So if Maria does not know the correct answer to a question, we want to know, is it in her interest to guess at an answer? So if we're trying to think of how many outcomes we're going to have here, we're going to have 2, which means she guesses it correctly or she guesses it incorrectly. So our setup is going to be the expected value is going to be P1A1 plus P2A2. So if we want to set up a table, just to make it a little bit better visually for us. So the first outcome is she guesses correctly. And if she guesses correctly, she's awarded 2 points. The probability that she guesses correctly, there are 5 possible answers for each question. There's only 1 correct answer. So that means it's going to be a probability of 1 over 5. Okay, and then for the next option is that she guesses incorrectly. If she guesses incorrectly, that means she's losing a half a point. If she's losing a half a point, that means it's going to be -1/2. Okay, so either she guesses correctly and gets 2 points with a probability of 1/5, or guesses incorrectly and loses 1/2 points, and that is going to have a probability of 4 over 5. There are 4 incorrect answers, 5 total answers. So that's going to be 4/5. Okay, so let's go ahead and set this up. So it's going to be the expected value is P1, which is just going to be the 1/5, times 2, plus P2, which is 4/5 times -1/2. So when you're plugging this in the calculator, hopefully we can do this by hand because we are just multiplying and adding fractions. But when you're plugging this in the calculator, you would get, actually let's just do it by hand just to remember here. 1/5 times 2 is 2/5. You just multiply the numerators. And then for 4/5 times -1/2, we know we're going to be getting a negative answer, so we're going to be subtracting. 4/5 times 1/2 is going to be 4/10. 4/10 simplifies to 2/5. So we get 2/5 minus 2/5. That gives us an answer of 0. So before, what I was going to say is if the numbers were a little bit nastier and you're plugging fractions in the calculators, just make sure you have parentheses around it like I do when I have it written down there. Okay, so we have an expectation, an expected value of 0. So that means over a long period of time, she's neither going to gain nor lose points by guessing. So you could say that it is in her interest to guess, but in the long run, it's not going to make a difference either way. Okay, for the next one, if she can eliminate one of the possible choices, we want to know, is it in her advantage or disadvantage to guess in an answer? So hopefully we know that it will be advantageous for her based on what we got on the last one. Out of 5 choices, now we're going to have 4 choices. So the setup is going to be exactly the same. It's going to be P1A1 plus P2A2. And if you want to set up the little table, our outcome is either she gets it correct once again, and she gets 2 points. And if she guesses it correct this time, the probability of doing so is going to be 1 out of 4 because she eliminated one of the choices. So now there's only 4 choices instead of 5. And the other choice was that she gets it incorrect, and she will still lose negative half a point. And now the probability is going to be 3/4 that she gets it wrong, because once again there's 4 options. There's 4 total options to choose from, and 3 of them are incorrect. So let's go ahead and do the same exact thing that we just did. It's going to be 1/4 times 2 plus 3/4 times negative 1/2. So if we were doing this by hand, we would get 2/4. We would get 2/4 minus, because it's positive and a negative for the second one, minus 3/8. We could simplify, or rather get a least common denominator with 8. So 2/4 minus 3/8 is the same as 4/8 minus 3/8. So I just got a common denominator of 8 by multiplying the first fraction by 2 in the numerator and denominator. So this is going to give us 4/8 minus 3/8 is 1/8. So since this is a positive answer, that means she's going to, on average, gain 1/8 point each time she guesses over a long period of time. So this one, it would be obviously in her interest to guess. Okay, couple more examples. So for an outdoor concert, event organizers estimate that 20,000 people are going to attend if it's not raining. 12,000 people will attend if it is raining. On the day of the concert, meteorologists predict a 30% chance of rain, and we want to determine the expected number of people who will attend this concert. So we have 2 outcomes, so it's going to be the expected values P1A1 plus P2A2, and with the table, outcome number 1 is that 20,000 people attend. So this is going to represent the number of people attending for this one. So the probability that 20,000 people attend is if it's not raining. There's a 30% chance of rain. That means there's a 70% chance that it's not raining, as a decimal is 0.7. Okay, and then the other outcome is that if it is raining, then 12,000 people are going to attend. There's a 30% chance of rain. As a decimal, that is 0.3. Okay, let's go ahead and plug these in. So it's going to be the expected value is going to equal 0.7 times 20,000 plus 0.3 times 12,000. And go ahead and plug that into a calculator, and we're going to end up getting about, well, first plug the first one into the calculator, we get about 14,000. Plug the second one in, we get 3,600. Add them up, and we get 17,300, or 17,600. So that means on average 17,600 people will attend the concert. Okay, next one. When Josh attends a charity event, he is given a free ticket for the $50 door prize. A total of 100 tickets will be given out. We want to determine the expectation of winning the door prize. So we're going to have 2 outcomes here. Either he wins or he loses. So once again, it's going to be the same setup that we've seen. So for the table over here, if he wins the door prize, that means he wins $50. There's 100 tickets with one winner, so that means the probability of winning is 1 over 100. And if he loses, he actually doesn't lose any money. So that net amount is going to be 0 because he got a free ticket, so he didn't pay for it. And the probability of losing is 99 over 100. So there's 99 losing tickets and 100 total tickets, 99 over 100. Or you can think of it as 1 minus 1 over 100. So we plug these in. We get 1 over 100 times 50 plus 99 over 100 times 0. So that whole entire second term cancels off because it's 0. We get 50 divided by 100, so we get 1/2, which we can write as 0.5 since we are talking money. So the expected value is 50 cents. So this means if he kept on going over and over again to this raffle and got this, or to this charity event and kept on getting this free door prize, if he averaged all of his winnings together, he would average out to 50 cents. Okay, and then another way to think of this is that if you averaged out everybody's winnings that got that free door prize, the average of their winnings would be 50 cents. Okay, so let's do similar ones here that look a little similar. So when Josh attends a charity event, he's given the opportunity to purchase a ticket for the $50 door prize. The cost is $2. 100 tickets will be sold. We want to know the expected value. Okay, so we're going to be using the same formula. We have two outcomes, either he wins or he does not win. So if he wins, he gets $50, but he spent $2 on the ticket. So you actually have to subtract them, 50 minus 2, and you get 48. So that's 50 minus 2. We have to remember it is the net gain or the net loss. So we have to take into account that he purchased it. So the probability of winning, there's one winning ticket out of 100 tickets total, so that's still 1 over 100. So if he loses, this time he loses $2. So that means we have to put -2 for losing. Okay, so the probability for losing is 99 over 100 because there's 99 losing tickets. So once we have this set up, we do the same exact thing that we just did. We get expected value is going to be 1 over 100 times 48 plus 99 over 100 times the -2. Hopefully we expect this to be lower than what we just got. So if we multiply this out, we get 48 over 100 minus, because of the negative, minus 198 over 100. We subtract them and we end up getting -150 over 100. Since we're talking money, let's put this as a decimal. That's going to end up being -1.5. So that's going to represent an expected value for purchasing one ticket is -$1.50. That means on average, you should expect to lose $1.50 every time you play this raffle. Okay, let's do one more before we get into the last thing. So 1,000 raffle tickets are sold for $1 each. One grand prize of $500 and two consolation prizes of $100 are going to be awarded. The tickets are placed in a bin. The winning tickets will be selected from the bin at random. Let's determine the expectation if he purchases one ticket. So this time there's actually, looks like there's three possible outcomes. So P1A1 plus P2A2 plus P3A3. And that is because we can either win $500, we can win $100, or we can lose. So if we set up the table, if we win the $500, that's actually $499 net gain, because we have to take into account the dollar that we spent on the ticket. And the probability of winning that is going to be 1 winning ticket out of 1,000 total tickets. Okay, next one is going to be if we win $100. So if we win $100, that's actually a net gain of $99, because that's going to be the 100 minus the ticket purchase. There are 2 of these prizes, so it's going to be 2 out of 1,000 for the probability. And then for the last one is that if you lose, so you don't win at all, that's going to be a net gain of -1, and there's going to be 997 losing tickets. So that's because there was 3 winning tickets, 1,000 minus 3, 997 losing tickets. So once we have that set up, hopefully the rest is pretty simple. So let's go ahead and plug all this in. So it's going to be P1 times A1. Let's pause it real quick. Okay, so P1A1 plus P2A2 plus P3A3. So if we go ahead and we combine all of these here, let's just multiply them first. So we have 499 over 1,000, and then we have plus 198 over 1,000, and then it's going to be minus because the next one's negative, and it's going to be minus 997 over 1,000. So we combine these, and we end up getting negative 300 over 1,000, which we should expect, well, which ends up being as a decimal, negative 0.3. Let me just move this other one down a little bit. So that means per 1 ticket, you should expect to lose 30 cents. So the next question is, he purchased 5 tickets. So we want the expected value for purchasing 5 tickets. So all you actually have to do is multiply 5 times what we got from that first one, because you're losing 30 cents per ticket. So we multiply that by 5, and we end up getting negative 1.5. So that means the expected value is going to be to lose $1.50 for 5 tickets. Okay, so for the last thing here is fair price. So the fair price is going to be the amount to be paid that's going to result in an expected value of $0. Okay, which should make sense. The phrase fair price, what is fair? Fair would be getting nothing. So you're not gaining anything, you're not losing anything. So to determine the fair price, what we have to do is use this little formula. Fair price is going to equal the expected value plus the cost to play. So for example, at a game of chance, the expected value is found to be negative $1.50, and the cost to play the game is $4. Let's determine the fair price to play the game. So based on the formula, we know the fair price is the expected value plus the cost to play. So the expected value is negative $1.50, and the cost to play is $4. So it's going to be negative 150 plus 4. That's going to end up giving us $2.50. Okay, so this one would result in an expected value of $0 for this game. Okay, so if they wanted to redo the game, because right now it's not fair because it's $4 to play it, if they wanted to redo it, they would make it $2.50 to have the expected value be $0. Okay, so that is it for this section.